Hey everyone, welcome to our notes on parallelograms. So the definition of a parallelogram is it's a quadrilateral, so it has four sides with opposite sides that are parallel. Now notice in this picture, the way we show that, we have one set of arrows here that's showing that the left and right side are parallel to each other, and then a double set of arrows top and bottom that's showing that the top and bottom are parallel to each other. Now I do need one set and then two sets of arrows, because if I had one everywhere, that would just be like, oh, I have four parallel lines, so that wouldn't make any sense because that would not be a shape. That wouldn't be a polygon. So here we begin our properties. Now you will be filling out next time in class a quadrilateral tree that you're not going to be able to use on assessments, but you'll be able to use it to kind of keep everything straight. This is why this chapter, in my opinion, is kind of difficult, because you have to remember which shapes share these properties, where does it begin, at what shape does it end, and so on. But hopefully, you know, with practice, we'll all master how to do this stuff. So our first property here says that if a quadrilateral is a parallelogram, then its opposite sides are congruent. So in this picture, we see these two sides are congruent, the opposite sides, and this pair of opposite sides is also congruent. And then the second property says if a quadrilateral is a parallelogram, then its opposite angles are congruent. So this angle is congruent to this one, and this one's congruent to that one. Next one says, if a quadrilateral is a parallelogram, then consecutive angles are supplementary. Consecutive angles means ones that are next to each other, not across from each other, not opposite. So they are next to each other. So what that means, these two angles are supplementary. Now if you think about parallel lines, that should make sense, because if these two lines are parallel, and this is my transversal, these two angles in here are consecutive interior angles. Those are the ones that are supplementary. If I think of these two lines being parallel, this one and this one, these are supplementary because they're consecutive interior angles. So that property should make a lot of sense if you consider parallel lines and their transversals. Okay, the next one says, if a quadrilateral is a parallelogram, then its diagonals bisect each other. So what that means, the diagonals go across, they connect the vertices across from each other. This diagonal right here came in and bisected, meaning split into two equal pieces, that diagonal. And then this diagonal did the same thing. He came in, or she came in, and split this one into two equal pieces. So the diagonals split each other in half. They bisect each other. So the two properties here, the diagonals of a parallelogram bisect each other, we just said that, and the one diagonal will split these into two congruent triangles. So if I was to draw in just one diagonal, let's say it goes right there, these two triangles would be congruent. In this case, what I drew is side, 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 but we knew in a parallelogram these angles are congruent, so then we could say it's side, angle, side, and so on and so forth. Okay, so each diagonal does this. So if I drew this same parallelogram, but the diagonal going this way, same case. Okay, it also splits it into two congruent triangles. So a parallelogram has opposite sides that are parallel. That's the definition of a parallelogram. So I would do the little arrows, double arrow here, double here. It has opposite sides that are congruent. So those two sides are congruent. These two sides are congruent. It has opposite angles that are congruent. So here and there. The diagonals bisect each other, aka they share a common midpoint. This would be the middle of both of them. And it has consecutive angles that are supplementary. So these add up to 180, these add up to 180, these add up to 180, and those add up to 180. Yes, four different pairs of consecutive angles that are supplementary. I didn't draw that in the previous picture, so make sure you either go back to that one and circle that all of them add up to 180, or just have that here in your notes. So then sometimes you're going to be given a problem where it's going to ask you, is this a parallelogram? And here are the ways to prove it. You can show that both pairs of opposite sides are parallel. You can show that both pairs of opposite sides are congruent, that both pairs of opposite angles are congruent, that one angle is supplementary to not one, but both consecutive angles. You could show that the diagonals bisect each other, or you could show that one pair of opposite sides is congruent and parallel. So here, I usually put a little asterisk next to this because it's not a property of a parallelogram, but if it is a way to prove that something is a parallelogram, because we are going to be proving what type of quads we're dealing with this chapter. We're going to be doing coordinate proofs. And so if you could show one pair of opposite sides are not only congruent but also parallel, that is enough to prove, yes, this is in fact a parallelogram. Okay, so we're going to be doing a lot of coordinate proofs in this chapter. We're going to have to show a shape is what it is. So here, if I wanted to do this using coordinate proofs, which we're going to do on the next slide, I would do slopes to show that both pairs of opposite sides are parallel. So I would have to find the slopes of all four sides. Opposite sides are congruent, I would use distance formula, which we're going to use a lot. That's the SpongeBob formula, distance formula. Both pairs of opposite angles are congruent. We are not going to be able to do that in a coordinate proof. Showing one angle is supplementary to both, not going to be able to do that. Technically, I mean, if they're perpendicular, we're going to be able to do some stuff, but just to find, like, if the angles were 60 and 120, I can't do that in a coordinate proof. Showing that the diagonals bisect each other, you would find the midpoint of each diagonal, and then the points should be the same, then it is a parallelogram. And then here you would pick one pair of opposite sides, do slopes and distance formula for one pair. Okay, so on the next page we're going to do one. I'm going to do it by showing that the opposite sides are parallel. So right here it says, show that A, B, C, D are vertices of a parallelogram. So when you label a parallelogram, if they tell you it's parallelogram A, B, C, D, which sometimes it's going to be written like this, when you draw it, like if you were just to sketch it for yourself, you could start at any vertex you want, but let's say I start here in the upper right hand corner, I have to either label it A, B, C, D going clockwise or counterclockwise. So I could go A, B, C, D. What I cannot do is something like this, A, B, and go left to right up top, and then C to D on the bottom. If you label your any type of quadrilateral like that, it's going to be wrong. You can't do that. You have to follow either clockwise or counterclockwise. You can't jump around. All right. So there are a few ways that we could prove that this is a parallelogram. I'm going to do slopes. Okay, so I'm going to do slope up, and I'm going to clearly label my work and make sure that you do that as well. I'm going to find the slope of AB, and I'm going to find the slope of CD. Hopefully they're the same. Then I'm going to find the slope of the blue sides, and hopefully they're the same. So the slope of AB is going to be y minus y. So I did 3 minus negative 1 over 1 minus 2. This is 4 over negative 1. This simplifies to be negative 4. If I wanted to, I could do negative 1 minus 3. That's fine as well. Another thing is, when it's drawn, I could do rise over run. So I could have gone up 1, 2, 3, 4. Going up is positive. Going left is negative. Okay? I could do the same thing here. Up 4 over 1. But you're not always going to have it drawn for you. So I'm just going to do it by hand. So the slope of CD, of that segment, is going to equal, from C to D, I'm going to do 5 minus 1 over 6 minus 7. And hopefully you see that this is 4 over negative 1. This just simplifies to be negative 4. Okay, so far I've only shown this pair of opposite sides is parallel. Now I have to do the blue sides. So I'm going to do slope of BC. So for BC, it's going to be 3 minus 5 in the numerator over 1 minus 6 in the denominator. This gives me negative 2 over negative 5. That's positive 2/5. And then I'm going to do the slope of AD. Oops, that should be an M. And that's going to be AD. I'm going to do 1 minus negative 1, change in y, over 7 minus 2. This is going to equal 2 over 5. So notice these two are equal, these two are equal. So I know this side's parallel to this side. I could have done rise over run as well. I could have gone up 2 and to the right 5. So remember, up and right are positive directions, down and left are negative. So here I could have gone down 2 and then left 5. So my rise over run is still 2 over 5. Okay, so now the final touch on a problem like this is to explain why something is what it is. So I would say because both pairs of opposite sides are parallel, ABCD is a parallelogram. And I don't have to write the word parallelogram, I could just draw a little parallelogram, which is nice. Had I proven this using another method, then I wouldn't say because both pairs of opposite sides are parallel. So we're going to practice that a lot in this chapter with these coordinate proofs, but the last sentence explanation has to support the answer you gave. So I'm going to go back to the previous slide and just say which ways we would or would not be able to use to prove a parallelogram or any other quadrilateral that we're going to study in this chapter. All right, so here's an example. It says, if ABCD is a parallelogram, how big is angle D? So, in order to find, there's no expression here. All I have in this picture are these two opposite angles. So I know that opposite angles, because it's a parallelogram, the opposite angles are going to be congruent. So I would subtract 3x from both sides. I'm solving for x here. I get x minus 9 equals 18, add 9 to both sides, x is going to equal 27. So that's using the one angle relationship, the opposite angles are congruent. How does that help me find the measure of this angle? Well, I know that the measure of angle A plus the measure of angle D has to be 180 because consecutive angles, the ones next to each other in a parallelogram, are supplementary. So those add up to 180, these two add up to 180, these two add up to 180, and these two add up to 180. So the measure of angle A I will get by plugging in 27 for x. So that's all measure of angle A, plus the measure of angle D is 180. So I get 108 minus 9, that's the measure of angle A, plus the measure of angle D equals 180. And I'm doing a lot of work here that isn't necessarily. I could have just plugged it in, but I wanted to show you the setup so you have it in your notes if you have to go back and study. So I would subtract 99 from both sides, and I get the measure of angle D is going to equal 81 degrees. Okay? And I could check that I did this correctly. When I got 27 for x, I could plug it in here and then plug it in here. Those two angles need to be exactly the same. Otherwise, I did not solve for x correctly. Example 3 here says, if W, X, Y, Z is a parallelogram, find the values of R, S, and T. Well, we could start anywhere we want. This is showing that, let me change my color here. This 7s plus 3 is showing this part of the diagonal. 8s is showing this part of the diagonal. So because the diagonals get bisected, I know that those two segments are congruent. So 7s plus 3 is going to equal 8s. Subtract 7s from both sides, and we get 3 is equal to s. Boom. Okay, now I also see that R is up here. This side and this side are congruent. The opposite sides of a parallelogram are congruent. So 4R is going to equal 18. Divide both sides by 4. 4 does not go evenly into 18, but I could reduce it, and it's 9 over 2, or if I wrote it as 4.5, that's okay, because that's still exact. I'm not rounding 4.5. 4.5 is what it is. All right, the last one, 2t. 2t fruity. Okay, so 2t is right here. This angle and this angle, because this is pointing here, it's kind of hard to mark that. These are alternate interiors, because if I was to think of the transversal and the z that we kind of draw in, those two angles are congruent. Also, this angle would be congruent to this angle because of this kind of z formation. All right, so we get a bunch of parallel, because of the parallel lines, we get a bunch of congruent angles. But in any case, 2t equals 4t, divide by 2, and t is going to equal 20. All right, so we've found all the variables that we were asked to find. And my picture ended up looking like a hot mess, but no worries, you don't have to mark all of the stuff that I did. I just want to make sure you were able to follow along. All right, so our last example here, given that FEDY is a parallelogram, find x and y. So let's see, a couple different things that we can do here. I know that if this angle is 45, then this angle also is 45, again, because they're alternate interior angles. So I can now do a few different things, and then I also know this one's 70. So one of the ways to solve this, I'm going to focus on each triangle's angles, right? Because I know the angles of a triangle have to add up to 180. So for this triangle here, it's going to be 70 plus 7x minus 5 degrees plus 45 degrees is equal to 180, because of the triangle sum theorem. So let's combine our like terms. We're going to have 7x plus 110 equals 180. I got 110 by doing 70 minus 5, that's 65. 65 plus 45 is 110. Subtract 110 from both sides, I get 7x equals 70, so x is equal to 10. I could do the same thing to solve for y. I could use triangle sum theorem, or I could just figure out that what this angle has to equal. If 45 plus 70, that is equal to 115, this angle here has to be 65 degrees. Another thing I could have done is plug 10 in here. 70 minus 5, that's 65. The opposite angles of a parallelogram are congruent. So lots of different ways to solve this problem. Even initially, I think I could have done something different to solve for x and or y to start with. So divide both sides by 5, and we're going to get y is equal to 13. Okay, happy Wednesday to everyone. Your homework in class, you're going to work on day 2. Make sure you come to class with any and all questions. Thank you for watching. Have a good one. Bye.